Okay, question 10. We've got some wind turbines. They're making some energy for the national grid. And it says, state 2 other renewable energy resources. So any 2 of these. Please work button. There we go. So tidal, biomass, biofuel. Clearly I enjoy tidal. I've put that in there twice. Hydroelectric, geothermal, and solar. Any 2 of those. Obviously not tidal and tidal. That'd be daft. The next one, we've got to calculate the efficiency. So we're going to need to use efficient, useful tools. So it's useful over total. Well, it tells us the input, so that's the total input. It tells us the output, that's the useful output. So calculate the efficiency, just divide those 2 numbers. And we can because they're in the same units. I'm just checking the units because we know that efficiency is a basic ratio. So 2.2 over 6.2 is 0.35 or 35%. Suggest a reason why it's impossible for the turbine to use all the kinetic energy. Well, if we imagine that we've got, say, a turbine blade, there we go, not a bad diagram. Well, the crucial part is wind needs to go around it anyway, because this is an aerofoil. But the main thing is there's going to be some friction, and the friction will mean that we get some kinetic energy transferred to thermal energy. So in the mark scheme, it says for the blade to work, wind needs to move to the other side. Fine. Or an easier answer is there's going to be some friction, and this will dissipate some of the kinetic energy into thermal energy in the air. Next one, we've got to compare nuclear fission and nuclear fusion. It's a common question, and you'll probably see on this paper just how much radioactivity there is. And this is a nice 6 marker, and it's learn this and learn this well. So nuclear fission, fissionable nucleus, like uranium-235, has a neutron with the correct velocity fired at it. That neutron is absorbed. This makes the nucleus unstable and it splits. This produces 2 daughter nuclei, some energy, and that's because a little bit of mass is lost and converted to energy according to E equals mc squared, and 2 to 3 neutrons, which cause a chain reaction. Advantage, it's already in use. We've already got nuclear power plants that use this, so we don't need any new technology, just develop the stuff that we've already got. Disadvantage, the waste is radioactive, or there's risk of a nuclear accident. So that's fission done. So it's a really nice way to get 3 easy marks. Now let's go into fusion. So now this is small nuclei like hydrogen are joined at high temperature and pressure to overcome the nuclei repelling. This produces larger nuclei like helium and some energy according to a small amount of mass is lost. This is transferred to energy according to E equals mc squared. Now let's go into the advantage. There's no nuclear waste. Disadvantage, it's difficult to contain the high temperatures and pressures of the plasma, so it's not yet fully practicable. However, it probably will be in time. So that's all of that done. That's question 10.